Now for the addition of integers procedure, add a, b positive integers c1 c 0 for j 0 to n minus 1 begin. D is the integral part of aj plus bj plus c divides 2, and sj is aj plus bj plus c minus 2d, c is d, and Sn is equal to c. The binary expansion of the sum is Sn minus 1 up to dot dot S1 S0 to the base 2. This is widely uses in the field of computer security, because the number theory having the important subtopics like divisibility, prime numbers, greatest common divisors, relatively primality, groups, rings, and fields. And these topics are very important and are very diversified and used in the higher level in the various security purpose, like for the coding and etc. Modern cryptography is based on number theory, a branch of mathematics concerned with the properties of integers. In order to understand how modern cryptographic techniques work and to estimate the extent to which they are secure, it is important to understand the basic of number theory. So we will try to keep it as simple as possible. Here, divisibility and divisors. We say that m divides n, or n is divisible by m if m is greater than 0 and the ratio n by m is an integer. This property underlies all number theory. So we have a notation for it: m divides n. We have already seen this. M divides n. This is the vertical line. M divides n, and we said that we say that m is a divisor of n. N is a dividend. Divisibility and divisors. Here are some relations. We are using the 6 important relations. If a divides 1, then a is equal to plus minus 1. If a divides b and b divides a, then a is equal to plus minus b. Any b not equal to 0 divides 0. If b divides g and b divides h, then b divides mg plus nh for arbitrary integers. M and n, we will discuss about the arbitrary integers. If a divides b and b divides c, then a divides c. If n is a positive number greater than 1 and d is the smallest divisor of n, that is greater than 1, then d is a prime. For prime numbers, a positive integer p is called prime if it has just 2 divisors, 1 and p. A positive integer that has 3 or more divisors is known as a composite. If an integer is greater than 1, is either prime or composite, but not both. So these are the 2 important notes. 2 is a prime, 1 is not a prime. The sequences of prime starts 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, etc. There are many, infinitely prime numbers, and the search is continuously going on. Prime numbers. Primes are important because they form the fundamental building blocks of all positive integers. Any positive integers n can be written as a product of primes, like n is equal to p1, p2, p2 up to dot dot pm. All are the prime factors of n is equal to this is the symbol of the product of all the prime factors starting from k equals 1 up to the m, pk, and p1 less than equal to p2 less than equal to p3 less than equal to p4 up to dot dot less than equal to pm. And this expansion is unique. There is only one way to write n as a product of primes, is non-decreasing order. This is also known fundamental theorem of the arithmetic. So this is very important relation like this.